Okay, we're going to go over how to convert moles to particles and particles to moles one more time. You will absolutely need your calculator for this, so I'm getting mine ready. Now, if you're in the first two rows, here's what you should notice. All your units of measurement for your known value are measured in moles. So on 3A through 3D, you are going from moles to particles. So the first substance is silver. Silver is an atom. So on 3A, your representative particle is going to be atoms. You're going to start it off by beginning with your known value, 0.250 moles of silver, which is Ag on the periodic table. You set up your conversion table. And because moles is your known value, you're going to have 1 mole of silver on the bottom so that they cancel out. And you're going to have 6.02 times 10 to the 23rd atoms of silver on top. Moles cancels out. So 0.25 times 6.02. I get 1.51 because I'm considering my sig figs times 10 to the 23rd atoms of silver. Whoa, atoms of silver. Next problem. We have 8.56 times 10 to the negative third moles of sodium chloride. Sodium chloride is a ionically bonded compound. So on 3B, your unit of measurement is going to be formula units. So we have 1 mole of sodium chloride, which is table salt. It is ionically bonded because sodium is a metal, chloride is a nonmetal. And we're going to put, whoops, wrong one. 6.02 times 10 to the 23rd formula units. Trying to squeeze all that in there of sodium chloride on top. Moles cancels out. And as I've shared with you all, I know the number one mistake that you guys are going to make is you are going to not put the right number in the right spot. And so we're going to do 8.56. Whoops. Wrong app. 8.56 times 6.02. I get 51.5. And you have negative 3 plus 23, which is going to be times 10 to the 20th formula units, but we're not done because it's not a proper scientific notation. So we're going to make it 5.15 times 10 to the 21st formula units of sodium chloride. Yes, Carson, die.
How do you know, like if it's going to be atoms, like for A?
Because silver is an element on the periodic table.
And then if it's you're given like a formula.
A formula unit is a compound that has a metal and a non-metal. You have to know that sodium is a metal and chloride is a non-metal. If you have a metal and a non-metal bonded together, that means that it is ionically bonded and it is a formula unit.
On the test, we put 6.02 times 10 to the 23rd atoms.
Well,
B would be getting.
we'll come to that bridge when we get to it, but that's why I'm glad you're asking that question now so you can differentiate. So let me ask you, take a look at 3C. What type of element is carbon? Metal or a non-metal?
Metal.
It's a non-metal. How about oxygen?
Non-metal.
So what do you call a non-metal and a non-metal? No, that's a metal and a non-metal. The one I just did, sodium and chloride, is a formula unit because it's a metal and a non-metal. What I'm asking you now is on 3C, you have carbon, which is a non-metal, and you have oxygen, which is a non-metal. So what do you call the compound with a non-metal and a non-metal? Begins with an M. If you go back to your notes, this is why I've been telling my AP Bio students this. You guys have to go back and look at your notes because 49 minutes a day is not going to make this happen. If you go back to your notes, I told you what, if I can get this to work. Right there. Representative particles. You have atoms, you have ions, you have molecules, and you have formula units. So if you have a nonmetal and a nonmetal, that means that it is covalently bonded, and we call those molecules. Like water is a molecule. Carbon dioxide is a molecule. So I'm going to tell you what I've been telling my AP Bio students. My AP Bio students have been doing some really tough stuff lately. 49 minutes in a class a day is not going to be enough. Right, Derek? Let's continue. Use a different color so this all doesn't get lost. All right. So the next one, we have 35.4 moles of carbon dioxide. Carbon dioxide is a molecule. So we have 35.4 moles of CO2, 1 mole of CO2 on the bottom, 6.02 times 10 to the 23rd molecules of CO2 on top. Moles cancels out. 35.4 times 6.02. I have 213 times 10 to the 23rd molecules of CO2. Now, your number is not exactly scientific notation, so we need to shift the decimal 2 to the left. So it's going to be 2.13 times 10 to the 25th molecules of CO2. And then the last problem, we have 0.425 moles of nitrogen. Max. We have nitrogen bonded with nitrogen, 2 nitrogens together. What type of element is nitrogen, a metal or a nonmetal?
Non-metal.
So we have a nonmetal and a nonmetal making N2. Is N2 going to be a molecule or a formula unit?
Molecule.
You got it. It's going to be a molecule. So for this problem, 0.425 moles of nitrogen, we're trying to convert to molecules of nitrogen. So 1 mole of N2 is going to be under 6.02 times 10 to the 23rd molecules of N2. Moles cancels out. So let's do the calculation. 0.425 times 6.02. I got 2.56 times 10 to the 23rd molecules of N2. Does anybody in those 2 rows have any questions? Do you feel competent in at least doing the math? As I want to keep saying this, the number one mistake I think that you guys will make, and it's going to happen, is you put the wrong number in the wrong spot. Like you put atoms on the bottom when you should have put it on top. Stuff like that. Okay, so for those of you that are in Jade's row and Max's row and Nick's row and Emma's row, let's see if you can just predict what's going to happen in these next ones. This is for Kendall's row and Colby's row. Determine the number of moles in each of the following. Show the factor label method. It's basically saying show your work. So we have 3.25 times 10 to the 20 atoms of lead. So this one is telling you the representative particle. Now you just need to convert it to moles. So our known value is 3.25 times 10 to the 20th atoms of lead. So we need to put Avogadro's number on the bottom this time. 6.02 times 10 to the 23rd atoms of lead is going to be under 1 mole of lead. So this is division. Whoops. So 3.25 divided by 6.02 my raw answer right on my calculator is 5.4 or 0.540 times 10 to the blanks. Let's see, we have 20 minus 23. 20 minus 23 is going to be -3 moles of lead. I need to fix that scientific notation. It's going to be 5.40 times 10 to the -2 moles of lead. Is it negative second or negative fourth, actually? So if I shift it to the left, it increases. To the right, it decreases. So it should actually be negative 4. So your answer should be 5.40 times 10 to the negative 4th moles. Carson?
So like, how did you know to put it on the bottom?
Because this is atoms right here. That's my known value. You need to cancel it out, so you put the like term on the bottom. Just like I did up here. What do you notice that all of these, what do you notice all of these have in common? Moles known, moles on the bottom. Moles known, moles on the bottom. They have to cancel out. So you have to put the like term, the term that is in common, on the bottom. So on 4A, my known value is in atoms. So that means I have to put atoms on the bottom of my conversion table. Okay, the next one. 4.696, or what did I say that? 4.96 times 10 to the 24th molecules of glucose. So it tells you right there. So let's go and get started. 4.96 times 10 to the 24th molecules of glucose. Glucose is C6H12O6. You guys should have learned that from bio. You can write glucose if you want. Carson, you tell me. For Avogadro's number, 6.02 times 10 to the 23rd molecules of glucose equals 1 mole of glucose. Where am I going to put 1 mole of glucose? Top or bottom? Okay, you sounded like you just guessed, and you guessed right. What is the unit of measurement right here?
Molecules.
Is molecules and mole the same thing?
No, that's what
That's why, okay. So 1 mole of glucose goes on top. 6.02 times 10 to the 23rd molecules of glucose is there. That cancels out. So we have 4.96 divided by 6.02. Your answer should be, your raw answer right out of your calculator should be 0.824. 0.824 times 10 to the, let's see, 24 minus 23 is 10 to the first moles of glucose. Now that answer is not your final answer. You need to fix the scientific notation. It should be 8.24 times 10 to the 0, which when it's 10 to the 0, you really don't need to write 10 to the anything anymore. It's just going to be 8.24 moles of glucose. 10 to the 0 is basically saying there is no scientific notation. Any questions on that? Carson?
So, when you divide, you subtract the extra.
That's right. When you divide, you subtract the scientific notation.
I would just put the whole entire formula in the calculator and then just divide it by the next formula, and I would just, for B, I got 8.24 times 10 to the 46.
Yeah, don't do that.
Okay.
Don't do that. Just do, in your calculator for that problem, put 4.96 divided by 6.02. And then in your own head, just do 24 minus 23, which would be 10 to the first. And then do all the adjustments by shifting the decimal to where it should be.
But for multiplying that,
For multiplying, you add them.
so it works.
This is division because when you're dividing the numbers, you're subtracting the exponents. When you're multiplying the numbers, you're adding them. This is division, so it's subtraction for the exponents. All right, next one, 1.56 times 10 to the 23rd formula units of sodium hydroxide. So 1.56 times 10 to the 23rd formula units, I'm just going to put form units of sodium hydroxide. We have 6.02 times 10 to the 23rd formula units of sodium hydroxide under 1 mole of sodium hydroxide. Oops. 1.56 times, or actually, excuse me, divided by 6.02, I got 0.259. 23 minus 23 is 0. So you really don't need to use scientific notation. So your answer is going to be moles of sodium hydroxide. If you wanted to put it in scientific notation, I would also accept this answer. 2.59 times 10 to the negative first moles of sodium hydroxide. Either answer would be fine. Okay, to save time, I'm going to skip the last one. For this one, for Emma's row and Nick's row, here's what I just want to ask you. I hope that you guys are getting the math, but let's see. Nick, what is my known value in 5A?
1.51 times 10 to the 15 atoms of silicon.
Okay, so you're converting it to moles. So you just tell me for the conversion table, what did you put on top and what did you put on the bottom?
Mole on top and the number.
Avogadro.
Yep, on top and bottom, on the bottom.
Emma, for 5B, tell me what you put on top and bottom of your conversion table.
On the top I put Avogadro's number, and on the bottom I put 1 mole.
Okay. David, for 5C, what did you put on top and bottom of your conversion table?
Okay, so on the top I put 1 mole, and on the bottom Avogadro's number.
Good. That is correct. And last one, Kayla, for 5D, tell me what you put on the top and bottom of your conversion table.
I put the 6.02 times 10 on top, and 1 mole on bottom.
Correct. Okay, I just want to be sure you guys are setting it up properly. The setup is more important than the math. All right. So that would have been your homework last night. If you have any troubles with that, be sure you talk to me because we're just going to continue to build and build and build. And remember what I told you, 49 minutes a day is not enough. You need to look at it on your own time. So let's switch over to your notes. And I want to start off our lesson for today. We only have 20 minutes. That goes by fast. I want to start off today's class with a problem that is reflective of what we did yesterday. Let's see. See if y'all can do this. Convert 3.59 moles of iron to grams. Adam, what is our known value in this problem? Keep going. Good. That's your known value. Nick, what are we trying to convert it to?
Grams.
That's right. That's your unknown. What conversion can we use that you guys have been taught so far that lets you go from grams to moles and moles to grams? Derek?
Applying the molar mass.
Molar mass is right. Very good. Where do you refer to find the molar mass of anything? Periodic table. Do you look at the atomic number or do you look at the mass number?
Atomic mass.
The atomic mass number, which is the mass number. So I do not have a periodic table on me and I don't have those memorized. Can somebody help me out and tell me what is the mass number of iron?
56.
56 what per what?
56.
Grams per mole. Okay, so on this problem, you start off with your known value. 3.59 moles of iron. You set up your conversion. Max, what do I put where? Do I put 56 grams on top or do I put 56 grams on the bottom?
On top.
That is correct. Moles cancels out. This is a multiplication problem. 3.59 times 56 equals 201.04. But hold on. How many sig figs is 201.04? That's 5. How many sig figs were in your known value? So what would 201.04 be as 3 sig figs? 201 grams of iron. That is your final answer. That was a breeze. Now, let's see if you can figure this out. Convert. Oh boy, I'm evil. 250 grams of iron to atoms of iron. Kevin, what is our known value in this problem?
256 grams.
All right, I said 250, but that's my fault. We'll make it 256. What the heck? It doesn't matter. All right, good. 256 grams of iron. What is our unknown value, Brennan? No. No. You have to read the problem. This is our known value here. The unknown is what we're trying to find. Atoms of iron. And that's not a chemistry question. That's just a reading question. So, do you guys have a conversion at your disposal that lets you go straight from grams to atoms?
No.
You do not. So this has to be a multiple step process. The two conversions that you will need for a problem such as this is you need A, Avogadro's number, and B, you need molar mass. So let's start off with finding the molar mass of iron. You guys said earlier it was 56 grams per mole. And for Avogadro's number, it is 1 mole is equal to 6.02 times 10 to the 23rd. Now, what is iron? An atom, an ion, a molecule, or a formula unit? Iron is not a molecule. A molecule is multiple nonmetals. Iron is just by itself. It is an atom. Okay, so who have I not spoken to? Scout. We're going to start off with our known value, 256 grams of iron. Which conversion should we use first to get rid of grams? Molar mass or Avogadro's number? Molar mass would be correct. So we have 56 grams per mole. Can you tell me where would I put the 1 mole, top or bottom? Are you guessing or are you telling me? Okay. Are you guessing or telling me? Or if you're guessing me, you're telling me. 1 mole of iron on top, 56 grams of iron on the bottom. So let's see if you can riddle me this. Why did you decide to put 56 grams on the bottom? How do you know you need to divide? It cancels out, Scout. They cancel out. Okay, if you stopped right now, would your answer be in terms of atoms? No. What would it be in terms in? Moles. And that means you're not done. So let's do the next conversion. Arshan, we're going to use Avogadro's number. Where do I put 1 mole, top or bottom?
Bottom.
Why?
Because it's the same term.
Yep, you want it to cancel out. Okay, if you stopped right now, what would your answer be in terms in? Atoms, is that what you want? Yes. So now you may do your math. What type of math do we do between 256 and 56? We do division. So 256 divided by 56. And then what type of math do we do between that answer and 6.02 times 10 to the 23rd? Multiply. Times 6.02. I got 27.52 times 10 to the 23rd. That is not a final answer because it's not the correct scientific notation. So I'm going to do two things in one in one stroke. I'm going to put it in right scientific notation, and I'm going to put it in the correct number of sig figs. 2.75 times 10 to the 24th atoms of iron. Did you guys get that? Yes, Arshawn.
At the beginning, you said it was 250 grams. What
That would have been 2 sig figs. That would have been 2.8. Okay. So that is an example where you have to have multiple conversions. Now, we have about 13 minutes left. I want to get to how to do your homework for tonight, okay? Yes, Arshawn?
Did you wait till around the end?
Yes. Wait till the very end. All right, guys. We are going to continue to do all this math. I'm going to go back and forth, back and forth. This is not going to be the last time. I want all of you to be pros on this. The last thing you can do for yourself is just sit there and let it completely wash over you and say, screw it. Throw your hands up. I give up. Heck of a time to give up. 16 years old and already giving up on life. Wow. So now, let's spend the last 10 minutes or so on the final part for today. This is going to help you with your homework. It's going to be moles and compounds. Okay. Determine the molar mass of CCl2, F2. Oh boy. How in the heck do we do this? Well, let's break it down. First, ID which elements are in this molecule and how many of each. Jade, what is the first element that you see in CCl2F2? Carbon. How many of them are there? Correct. Max, what is the next element that you see? Chlorine. How many are there? Correct. And Kendall, what is the third and final element that you see in there? Correct. And how many are there? Very good. Okay. That's the first thing you guys have to do when you get a problem like this. And this is what your homework is going to be tonight. You need to find the molar mass of an entire molecule or an entire compound. Now, step 2. Identify the molar masses of each element that's in that compound. Okay, so be referring to your periodic table. What is the molar mass of carbon? You can round it to the nearest whole number. Carson Dye? 12 what? How do we say molar mass? No, that's atomic mass. It's the same number, but you're using it for a different purpose. What is the unit of measurement for molar mass, guys? Grams per mole, correct. Okay? For fluorine, or not fluorine, let's do chlorine. What is the molar mass of chlorine? Jade? 35 what, Jade? Don't make me keep having to ask of what? Carson Cheeseman, what is the molar mass of fluorine?
18
Of what, Carson?
grams.
Look at what the units of measurement are that we're saying.
Moles?
Which one?
Oh,
Yeah.
it's 19
19 what, Carson?
grams. Am I saying it wrong?
No, you're saying it wrong. Somebody help her out?
Moles? I don't know how to say it.
Carson, look at me. Look, grams per mole. Say it.
Grams per mole.
Okay. So this compound that we're looking at has carbon, chlorine, and fluorine. Now, here's an extra part. This is going to be like 2A. Multiply the molar mass by the number of each atom present. This is the third and final step, or actually the second part of the second part. For carbon, how many carbons were there? So 12 grams per mole times 1 is still 12 grams per mole. Chlorine, you guys said is 35 grams per mole. How many chlorines were there? Okay, do it in your head. What's 35 times 2? You got this. 70 grams per mole. And fluorine was 19 grams per mole. How many fluorines were there? 2. So what's 19 times 2? 38 grams per mole. What do you think you do with those three products? You add them. So you may need your calculator for this. 38 plus 70 plus 12 is 120 grams per mole. This is the molar mass of CCl2F2. Okay. Yes.
Should we always round the atomic mass to the whole number?
Unless I tell you otherwise, yeah. Let's try one more. All right. Here's an old school cartoon from the 1990s, early 2000s. King of the Hill. I'll tell you what. What is Hank Hill self-related? Somebody's got to know. Propane. I sell propane accessories. I want you to tell me what is the molar mass of propane. Count them up. You have 2 minutes. C3H8, clean burning, efficient. Propane. I love my propane. Whoa! I want you to find the molar mass of propane, C3H8. Okay, judging from all of your shuffling and packing and getting ready to go, I assume that you 100% get this. So what is the molar mass of carbon? Thank you, Jane, and everyone else who said it. 12 grams per mole. How many are there? So what's 12 times 3? 36 grams per mole. Hydrogen, what is its molar mass? 1 gram per mole. How many are there? 8. What is 1 times 8? Genius. What is 36 plus 8? 44 grams per mole is the molar mass of propane. All right, that is your homework tonight. Do it to it.